with our rational exponents. Now, our first kind of main theorem that we have, this concept here, let a be to the 1 over n, be the nth root of a, and let n be a positive integer, such that a to the m over n is equal to a to the 1/nth to the m is equal to the nth root of a to the m. So we can break it back down, and we did a little bit of this yesterday. The m over n into the m, nth root of a to the m. So we can break this down. So we can go either direction. Either I can take a to a fractional exponent and rewrite it as the nth root of a to the m, or we can take it as the nth root of a to the m power and rewrite it as a to the m over n. We can go in either direction. We can take this in either direction. Our other one is a to the negative m over n is equal to 1 over a to the m over n. And then we could do the exact same thing as we did and pretty much end up saying that this is the nth root of a to the m. Because again, if an exponent is negative, if we want to make it positive, we either move it from the numerator to the denominator or the denominator to the numerator. We can move it in one direction or the other. Okay. Evaluate each exponent. Now, we could type some of these into the calculator and get our answer, but let's do this by hand. 16 to the 3/2. Well, according to our first kind of concept, what we can do is I can take 16 to the 3/2, and what we can do is we can rewrite this as 16 to the 1/2 to the 3rd, because we can split those back apart. Now, 16 to the 1/2 is the same as the square root of 16. Square root of 16 is 4. Well, that gives me 4 to the 3rd, and 4 to the 3rd is 64. Now, most calculators could have given us 16 to the 3/2 as 64. But if we're having to work this out by hand, this is what we will end up getting. Any questions on this here? Okay. Let's look at the next one. 32 to the negative 3/5. Now, we could do the same thing here and plug this into the calculator and get an answer. Or we can work it out using these concepts. And because the exponent is negative, what that means is I can move it to the denominator. Because if I move it from the numerator to the denominator or denominator to the numerator, the variable, or not the variable, the exponent goes from positive to negative or negative to positive. It's going to change. And we can do the exact same thing we did on the other one. 3 is going to go to the outside. If I can. 32, and it would be to the 1/5. 32 to the 1/5. Because the 5th, the 5 on bottom is our root, the 3 on top is the exponent. Now, really what 32 to the 1/5 is saying is that I have the 5th root of 32 to the 3rd. Well, do we know a number times itself 5 times? That would give us 32. That would be 2. Because 2 to the 5th would be 32. So we can reduce it like this here. And 2 to the 3rd is 8. So this would give us 1/8. I think that's the same thing you got in the calculator. Yeah, 1/8. Mm-hmm. All right. We can look at 2 more of these here. We'll look at 2 more of these and then we'll move on to something else. So when we look at this here, 64 to the 4/3, we could rewrite this as 64 to the 1/3 to the 4th. Because we can split that exponent up into 1/3 and 4. Because 1/3 times 4 is 4/3. Any questions on this here so far? Well, we can rewrite 64 to the 1/3 as the 3rd root of 64 to the 4th. Okay. And at this point here, we need to find out what the 3rd root of 64 is. And what number times itself 3 times is 64? Huh?
You said what number times itself?
Times itself 3 times. Well, twice would be 8. So we need a number smaller than 8. 4. Mm-hmm. It would be 4. And we'd really have 4 to the 4th now. Well, 4 to the 3rd is 64, so we can do 64 times 4, which is 256. Or we can do 4 to the 4th in the calculator, and it would tell us 256. I have a feeling also if you did 64 to the 4/3, it would give you 256. Okay. Any questions on anything we've done so far? Type 16 to the negative 5/4 in the calculator and see what you get. What answer did y'all get? What is that as a fraction? What is it? 1/32. Again, on the graphing calculators, if you hit the button that says math, the first option should be fraction, F-R-A-C. and we can use that to convert it back over if it gave it as a decimal. Now with those there in the numerator, so if you don't want to type it as a fraction on the graphing calculator, -5 divided by 4 also works. So 16 to the -5 divided by 4 would give us the same answer. Now if we did this the other way, we would move it to the denominator. And this here would be the same as 1 over the 4th root of 16 to the 5th. And well, the 4th root of 16 is 2. And the 2 to the 5th would give us 32. So doing this in either way will work. The only real time we would have to do this by hand is if it doesn't simplify out completely, if it doesn't fully simplify, then we're going to have to do some hand calculations or do some calculations ourselves. All right, we'll do 3 of these and then move on. Evaluate 9 to the 1/5 using a calculator. So what can we do? We can do 9 to the 1/5 and see what we get. One 1.4 5 1.55. And that's it, because when we evaluate these with the calculators, we just type them in. Now we can do 12 to the 3/8 in the calculator. And if we do 12 to the 3/8, and last but not least, the 4th root of 7 to the 3rd. 4th root of 7 to the 4.30. And then I assume the next number is less than 5. Yeah. I would go on and make sure, especially on big ideas math, if it is 0.30, go on and put 0.30. Since it asks for 2 decimal places, it's going to want 2, even if it is 0. Questions on this here? All right. I don't think we need to look at any more of those. And that brings us to the last topic that we're going to look at today. 4x to the 5th equals 128. Find the real solutions of this here. To solve the equation of the form UN equals D, where U is an algebraic expression, and algebraic expression, take the nth root of each side. Okay. Steps. 1. Get variable by itself. Step number 2. Take nth root of both sides. And the last step is solve. Okay. Give you all a second to write those steps down. So looking at this here, is the variable by itself? X to the fifth equals 128. Is the variable by itself? Well, no. What's with it? 4. So what do I need to do? Both sides by 4. When we divide both sides by 4, we'll get x to the fifth equals 32. Now at this point here, we would do what? Step 2, take the nth root of both sides. So what nth root will I take? 5. Because for the fifth root, bless you, to get the fifth root, that fifth power, x to the fifth, to simplify down to x, I need to take the fifth root. Because these will cancel out, leaving us with x is equal to 2. And again, it's just x equals 2, because if you remember back to kind of the end part of last chapter, if you have those notes right there, it is our last key concept in this here, that if it is an odd root, well, if the number was negative, we got one root, we got one solution. If it was 0, we got one solution. If it was positive, we got one solution. And that's really what this is coming back to. The only time we'll get more than one solution is if it's an even root and the number inside the radical is what? Positive. Is the only time we'll have 2. So here we'll just have 1. Did we solve it? Well, yes, x equals 2. And that's it. Questions on this here? Okay. Is the variable by itself? Yeah, I'll need to fix step 1. Let's rewrite step, well, let's put a notation in there. Because I said get the variable by itself. LF, not FL. Self. Why don't we say variable or term? Because really we're wanting whatever it is to that power by itself. Now it worked out for the first one, we could say variable. Or we can say term to a power. You don't have to write that whole thing out as long as you know what it means. The term to that power is what we need by itself. Is it by itself? Well, yeah. The parentheses to the fourth power is by itself. Yes? Bless you. Bless you. And the reason we do this is because we do have the x minus 3 inside the parentheses. Yes? Well, the only way to move that 3 is if I get rid of the parentheses. Because I have to get rid of the parentheses, some way to get rid of that 3. Now, it might be very tempting to just say we can add 3 to both sides. But really, x minus 3 to the fourth is saying what? I have x minus 3 times x minus 3 times x minus 3 times x minus 3. Because whenever we have that power, it's saying it's multiplied by itself that many times. Yes? Well, just adding 3 is not going to get rid of that 3. There's a lot more in depth into it. Yes? Okay. So we can really say it is by itself because there's nothing else outside of this term that is to this power. So how can I get rid of the exponent? Well, we can take the what? Fourth root of both sides, because the fourth root and 4 would cancel out, leaving us with x minus 3 is equal to the fourth root of 21. Now, 21 won't have a fourth root, because the 2 to the fourth power is 16. 3 to the fourth power is 81. So there's a big gap between those two there. And if we typed it in, we're going to get something close to 2.2 going on out, would be my guess. And that's not because I know the fourth roots. It's just, well, since 2 to the fourth is 16, 3 to the fourth is 81, 21 is closer to 16, so it's going to be closer to 2. Now, how many different answers did we say when we have an even root and positive number? We could have 2. So we have to include plus or minus. Because whenever we take the even root of a positive number, we're going to have to add that plus or minus. Well, that takes us through steps 1 and 2. Step 3 is what? Solve. Okay, well, we didn't have to do it on the first one, but we will have to solve here. Now we can add 3 to both sides. And we would get x is equal to 3 plus or minus the fourth root of 21. Now, if we wanted to, we could go on and split these out. And this point here, you're just going to have to plug these into the calculator, because I am not going to make you go through the process of, and I rounded to the second decimal place on both of these here. I'm not going to make you go through the process of finding the fourth root of 21 by hand, because square roots are hard enough as it is, let alone doing fourth roots by hand. It's not something you would want to do. So, big idea is it's going to take one of these two. On a test or quiz, I would be perfectly happy with 3 plus or minus the fourth root of 21. That is the answer. It's not any more. It's more accurate than having to round, but I'll take either one. I'll take either one. So if you do convert it to a decimal, I need both. Put the plus or minus for this one here, or you can leave it in the radical form. Either one works. Questions on this here? All right, find the real solutions for 5x to the third equals 320. So our first step is to get the variable or term by itself, term to a power by itself. Is it by itself? No, so what do we need to do? Divide both sides by 5. X to the third is equal to 64. 5 goes into 32 6 times, which is 30, which gives us 2 and 0, which is 20, and it goes into it 4 times. Okay, now we need to take the nth root of both sides. So what would the nth root be? We take the third root because we want the exponent with x to become 1. Third root of 64 is 4. That's it. Are we good with this here? Yes? Okay. Okay. Yeah. Okay, let's look at this one here. So, is the variable or term to the power, to a power by itself? Yeah, so what can we do? We can take the fourth root of both sides. Now the fourth root and 4 will cancel out, leaving us with x plus 3 is equal to. Right, it doesn't give us a whole number answer. Yeah. I'm going to leave it as the fourth root of 24 because it doesn't simplify completely or at all, so it doesn't work quite well. Because this is the same as 2 to the third times 3. Because 8 times 3 is 24. 8 is 2 to the third. So there's no way that we can reduce this and get whole number answers. What do we need to do next? Minus the 3 from both sides, which will give us x is equal to negative 3 plus or minus the fourth root of 24. And that's it. Any questions on this here? All right, I think we're good with that one. Let's look at this one here. Well, I lost the calculator. Okay, so I changed the problem a little bit to make it a little bit more interesting, or at least what I think is a little bit more interesting. Okay, so the first thing we need to do is get the variable or term by itself. So what do we need to do? So we can divide by 1/2, or what else could we do? What can I do to 1/2 to get it to go away? Because we can divide it by 1/2, or we can by, not 1/2, but what's 2 times 1/2? 2 times 1/2 is 1. So we can do it in either direction. Well, apparently. Because we can divide this by 1/2, which is fine. Or we can multiply it by 2. Either one will give us the exact same answer. Now, 512 divided by 1/2 is 1024. So it'd be the same as if we multiplied it by 2. Okay. We've got the term by itself, so now we can take the nth root of both sides. And our nth root would be what? 10. Because the 10th root and the 10 are exponents would simplify, leaving us with x plus 3 by itself. And it is 2. Now, it wouldn't be just 2. We'd also have to have what? Plus or minus 2. Because we took an even root, and it's a positive number, we're going to have to include the plus or minus. And last but not least, we can minus 3 from both sides. We can solve. So we have x is equal to negative 3 plus or minus 2. Well, wait a minute. Can I simplify that further? Well, yeah. Since we don't have radicals, I can actually do negative 3 plus 2 and negative 3 minus 2. Well, negative 3 plus 2 would be negative 1. And negative 3 minus 2 would be negative 5. And both of these will work. That's it. I know that there's still some more example problems in your note sheets, but I feel like y'all have a good grasp of what we're doing with this here. Yes? Okay.